This video is about the worksheet of supplementary questions that you got for complex numbers, specifically exercise 34, question 10. And in this question, we're told that 1w and w squared are the roots of z cubed minus 1 equals 0. So since we're talking about the roots of this equation, we're really going to be dealing with what z is equal to. So we need to start off by solving for z. Of course, z is a complex number. So I'm going to bring the 1 across the equal sign, and then I'm going to write that right-hand side as a complex number in rectangular form. But to deal with powers, I need to have it in polar form. So pause the video for a second, convert this into polar form, and then play and see if you're correct. So in polar form, this complex number is 1 cos 0 plus I sine 0. Now I want to work out z, so I want to bring the cube from the left-hand side of the equation to the right-hand side. It'll be a power of a third, but as I'm doing that, I must also take into account the need to write my angles in general form. So don't forget, any time that I apply a fraction power, I need to include my general form of n360. Now I'm going to apply de Moivre, which is just using my power, applying it to my modulus, and then multiplying it by the angles. And I can tidy this up slightly to give me z equals to 1 cos n120 plus I sine n120. And now, because I'm going to have 3 roots, I need to put in my 3 values of n, starting with 0. So z equals to 1 cos 0 plus I sine 0, z equals to 1 cos 120 plus I sine 120, and z equals to 1 cos 240 plus I sine 240. Now the first part of the question actually asks me to add these roots together. And since it's a little bit awkward for me to add my complex numbers in polar form, because I'd be having to add, for example, cos 120 and cos 240, which I could do using trig, but it's a bit of a nuisance. It's probably easier for me to actually take these complex numbers and convert them back into rectangular form before I do this part of the question. So to make things simpler for myself, I've just converted those back into rectangular form here, and of course you're just doing that using the calculator. And now I'm going to prove that 1 plus w squared equals to 0. Now you might kind of wonder, well, what one's w and what one's w squared? 1 is obviously my first root. W and w squared are actually interchangeable. If you were to square this first root, minus a half plus root 3 over 2i, you'd actually get this root. And it would work the other way as well. If you were to square this root, then you'd also get back to the previous one. So actually you can think of either one of those as being w and either as being w squared. So now all we have to do is just add these 3 roots together and see do we get 0. Don't make the assumption that I need to actually square anything here to get w squared. They've told me in the question that the 3 roots are 1w and w squared. So I know that w squared is already contained within these set of solutions. So there's no need to go squaring to get that. So just getting rid of the brackets there and having a look at the resulting terms, I can see that 1 minus a half is 0. And plus root 3 over 2 minus root 3 over 2 is 0. So I end up with the result of 0 equals 0. I was asked to prove that 1 plus w squared equals to 0, so I'd like to conclude by stating that. So this implies 1 plus w squared equals 0, and that's the end of part 1. It then says, for part 2 of the question, hence find 1 minus w squared to the power of 5. Now, since they've got the word hence in here, that leads me to realise that I'm going to have to use something that I did in part 1 to work out part 2. And actually, part 1 makes part 2 really accessible. So I don't even need to get too caught up here with evaluating 1 minus w squared. I can try and take what I got in part 1 and manipulate it to end up with this result. I'm just going to ignore the power of 5 though for a moment. So I know that 1 plus w squared equals 0. That's my result from part 1. And I want to end up with something that has minuses in front of the w and the w squared. Well, I could do that pretty easily because I could just multiply this entire equation across by minus 1. And if I do that, I'm going to end up with minus 1 minus w squared equals 0. Now this isn't exactly what I'm looking for, but it looks an awful lot like what I have in the bracket here. The only problem is this minus 1. So how could I change this minus 1 into a plus 1? Well, how do I get from minus 1 to plus 1? I can just add 2. So if I add 2 to both sides of my equation, I'll have a 1 on the left where I want it. Okay, so tidying up slightly, that means I now know that 1 minus w squared equals to 2. Great, because all I want to do now is figure out what this is to the power of 5. And it's easy to put 2 to the power of 5. 2 to the power of 5 is just 32. And that's my solution for part 2 of the question.